All right, let's try example number 4 here. So the difference between consecutive perfect squares is always an odd number. So let's use inductive reasoning to show whether or not this is a valid conjecture. Does anybody know what a perfect square is?
Is that like a decimal?
It wouldn't be a decimal, no.
Like something that can times itself and times it, looks like something that times itself.
So if we multiply a number by itself, yeah, then we get a perfect square, right? So like 1 times 1 is 1. So 1 would be a perfect square. 2 times 2 is 4. I know the 1 times 1 always gets in there, right? It's all good. Okay, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Yeah, okay. So we have perfect squares. Now again, if I gave you a couple extra minutes, I'm sure you would have all had those, no problem. Okay, those are a bunch of perfect squares. How many perfect squares are there? A lot. What we would consider to be an infinite number. Okay, so we could always have perfect squares and keep on going and on and on and on and on and on. Now, the question is asking, okay, the difference between perfect squares is always an odd number. Okay, so consecutive means side by side. So these would be all of our perfect squares, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. Okay, and we could keep going. Now, if we were to take consecutive ones and subtract them, that's what it's asking. Remember, difference means to subtract. Okay, sum is to add, product is multiply. Okay, so those are things to kind of think about. If we're to subtract, let's do 4 minus 1. What's 4 minus 1? 3. Okay, is that an odd number? 3 is an odd number. Okay, so 3 is an odd number, so that one works. Now, it's sometimes nice to have more than one example of things that work. So let's try another one here. Let's see if it works again. 9 minus 4 is 5. Okay, I know sometimes those like basic subtraction can be like the toughest, right? Okay, 9 minus 4 is 5. Is that an odd number? Yeah. So 2 for 2. 16 minus 9. 7. Okay, is that an odd number? Are we seeing a pattern forming? Yeah, what's 25 minus 16? 9. Okay, these are all odd numbers, right? And in fact, they're going up by 2s. That's just another pattern that we can say, or that we can see. So, is this valid? The difference between consecutive perfect squares is an odd number. We've shown 4 examples of it. Can we assume or make a conjecture that this is going to continue on? Yeah. So we can say that the conjecture seems to be true based on our evidence. Okay, there's our evidence. Boom. 4 minus 1 is 3. Done. 9 minus 4 is 5. Done. Okay, they're all odd numbers. And it seems to be working out. And if we keep going, we're going to figure out that it keeps on going. Okay, and the more we do, the better we can be sure about it. Okay, so that's something that we can be sure about. Now, anytime that we have anything like this, okay, where we kind of see a pattern forming, it shows that we have, in fact, we can make a conjecture about that. Okay, we can make a conjecture about what we see. The more evidence we have, the more solid our hypothesis will be, or our conjecture will be. Okay, so does that make sense? Yeah. Okay. One thing I could do here, and I'm going to pick on Chandler this time. Okay, I see Chandler's wearing glasses. Okay, and every single class that Chandler's in, he's always wearing glasses. Can my conjecture be that Chandler needs to wear glasses to see good? Probably. Probably, right? Okay, he probably needs glasses, because of his eyesight. That would make sense, right? Okay, based on that conjecture. And there's a few others of you that I could make that same conjecture about. But that's, right? Does that make sense? Okay, that's kind of making a conjecture about something.